There we go. Continuing lectures in section 4.1, we're going to start doing this idea of proving identities. And so the strategy is you want to take a look at one side of the equal sign or the other, and then you want to do a simplification. And so we don't spend a lot of time on this, but it's really easy to prove something is not true. And just to refresh your memory, if you have an equation that looks like this, and you want to prove something's not true, you only need to find one example to prove that it's not true. So proving things that are not true are easy, and you could just pick any value of x, and here the book picked pi over 4, 45 degrees. Plug it in, get those values. You can see you don't get 1, but you get square root of 2. So that should not be too bad of a process. The proving things are equal, I think, is a challenge. And so here's a couple guidelines or strategies, maybe is a better word, on how to proceed. You have to start with one side or the other, and you will see that usually picking the more complicated side is the best, because it's usually easier to take something complicated and shrink it down to something simple than to take something simple and try to make it complicated. And then you have to use the known identities and you have to label them. You know, as we started the process in the last lecture, label each step. And when you're stuck, make everything sines and cosines. Those are by far the most important, like I said, and you'll see that the manipulation becomes much easier when those are the only two variables that you have. So let's walk through a couple examples here. And so the first one that the book has is cosine of theta, and then secant and minus cosine on one side, and sine squared on the other. What's more complicated? Well, definitely the left side is more complicated. So let's start with that. So again, we pull up the whiteboard and do a few of these. And so here's what we have. Okay. So what to do? Well, the first thing I would do is get rid of secant. And so that's the reciprocal idea, right? Reciprocal identities. And you get plug in 1 over cosine minus cosine of theta. So another strategy that's usually really good to do when you're doing these is to find the common denominator, or maybe even better now, what we could do is multiply cosine through on this case, right? And so basically this is an algebra step. So you don't have to do this, but cosine and cosine would give you 1. And that would be minus cosine squared of theta. So technically you don't have to write anything here. So the next step you do have to write. Again, that's the Pythagorean identities. And 1 minus cosine, remember sine squared plus cosine squared equals 1. And so when I bring this on the other side, this equals sine squared of theta. And you can see those are right. And QED is a Latin term meaning you finished and now you're ready to move on. So I remember my old trig teacher always used that. So I kind of bring it along with me. So you could try to go the other way, but you would find that I think it's a little bit more complicated when you do it that way. So let's take a look at another one. Whoops. Let me just write it up here on the whiteboard. So cosine, they use the letter U. So just follow on some of the slides we have here. So if you look at them. So if you look at this, both sides are reasonably complicated. Usually fractions are more complicated. So what I would do is work on the left side. I've done this problem both ways now. And so maybe in our Zoom class, I'll do the right side, but let's focus on this side because it shows another interesting technique. And that's this idea of multiplying by what I like to think of as the conjugate. Because the idea is that if you think about this, 1 minus sine squared is the number 1. And that's a really nice number to have in your denominator, right? So if we start with cosine of u, 1 minus sine of u, and say like we multiply 1 plus sine of u on both up and the bottom. So you really don't have to write anything here because you're writing out what? You're multiplying by the number 1, which is really, you can do that in any equation. And so what happens on the top? Well, what happens on the top is that you would get cosine of u, 1 plus sine of u. And what do we have on the bottom? 1 minus sine squared. And you have to remember 1 minus x times 1 plus x. Just to do that for you, it'd be 1 minus x plus x minus x squared. So you see the conjugate idea is that you get rid of that center term. And so when doing that, now the next step is to do the Pythagorean identity again, right? And that would be here, right? And then you could substitute that with cosine squared of x, right? So you have cosine of u, 1 plus sine of u, and then cosine squared on the bottom. I think up at the top, I said you want to make that a 1. I meant to say you could substitute cosine squared in. So now, so this is the Pythagorean identity, which is written quite poorly. So let me rewrite that for you. And you can abbreviate this way, that's fine. And so now we do a little bit of algebra, right? We have 2 cosines on the bottom, 1 on the top. So you cancel one of these out. And you have 1 plus sine of u over cosine of u. And so remember when we split up these fractions, what ends up happening? Well, the cosine goes under both the terms up in the numerator. So you could rewrite it this way, right? So we have 1 over cosine, and so these are the reciprocal identities that we showed you. And so 1 over cosine equals secant of u, and sine over cosine, hopefully we all know that, is tan over u. And there's another QED for you, and proof completed. So when you walk through these, there's quite a few of them that we're just using basically the basic identities right now. And we're going to do some more complicated ones as we continue to move forward. But I think it's worth going through some more examples. So let me do at least one more. So I paused it, so I finished writing this equation up there. I needed to find it. So, but here it is. And you look at this, and both sides are complicated. And sometimes the strategy is take one side and simplify it, and then take the other side and simplify it. That one I think is quite challenging. And so I'm going to demonstrate that in this case. So let's take this side to start with, right? So if we take this side, what we could do is we could split it up, a little bit of algebra here, so we really don't need any description, but you see how we take that denominator and put it under both factors that we had, for both terms that we had in the numerator and the top. So this is the reciprocal, right? Identity. And so that would be secant, right, of theta. And cosine over cosine would be +1. And so maybe we can make the other side look that way too. So what would be the strategy on that one? Well, let's take a look. And this is good because we haven't used this identity again. If we use the Pythagorean identity, and again, it's handy to have this sheet. Like the only one I know is sine squared plus cosine squared equals 1. You can see that we have this one as well. Tan squared of x plus 1 equals the secant squared of x. So you see, I forgot my square. So you could see that if we simplify this for tan squared, it would look like secant squared of x minus 1. So you could see we could use the Pythagorean identity and put secant squared minus 1 on the top, and we have secant, put my thetas in there, minus 1 on the bottom. So you remember when we did the idea of the conjugate where we multiplied 1 minus sign and 1 plus sign together? Well, here we want to do a little factoring. And what factoring are we doing? We're going to factor out secant of theta minus 1 on the top. And if you multiply it by secant of theta plus 1, you would get secant squared minus 1. And why are we doing that? Well, the hint should be is you're trying to make it look like what we got over here on the left side, secant minus 1. And by doing that, we could do some algebra here, right? Getting rid of both of them, and you could see here we get secant of theta plus 1. Again, QED. So a lot of students ask me, well, how do you know what to do? I don't. I mean, you have to just start plugging and trying different ideas with regards to that. And so when you walk through these types of calculations, sometimes it's like, just try something. And if something doesn't work, you have to start over again, unfortunately. And so that's what makes it a little bit of a challenge in the sense that there are times where you go down a path that isn't going to help you. And so you have to go back, retrace your steps, as they would say, or maybe even just start over. So this is section 4.1. And again, this is doing some trig simplifications and identity proofs using what we call the basic identities, the reciprocal identities, and Pythagorean identities. And yeah, as you'll see through, as we walk through the next couple sections, we're going to introduce more identities. Hope this helps.